Hello. In this session, we're going to discuss some innovative concrete masonry solutions. My name is Sam Rubenzer. I'm the founder of Force Consulting and the managing director. I'm a licensed structural engineer in the state of Illinois and a professional engineer in a lot of Midwestern states. I have my engineering degree from the University of Minnesota and an MBA from Marquette University. Here at Force, we're a team of engineers with a lot of different masonry design experiences through delegated design, direct design, and we've been consultants to the masonry industry for the last 15 years. Talking about innovation, I think it's always really important to kind of consider a quote like this. Learning and innovation go hand in hand. The arrogance of success is to think that what you did yesterday will be sufficient for tomorrow. So certainly everything that we're talking about today in terms of innovation, things that we are doing for masonry design, we need to keep moving, we need to keep progressing, certainly in masonry and all other areas of structural design as well. But so this is just kind of one step. Here in 2025, we're looking at some ways to be innovative with concrete masonry. So some of the things that we're going to look at, prefabrication is certainly going to be very much a part of what our discussion is going to be today, how you can prefabricate masonry to achieve some pretty challenging constructability issues, whether it be site issues or time frame issues or building on site versus building in a controlled environment. So prefabricating masonry either on or off site and how that can impact delivery. Look at collaboration across different disciplines and different project teams to look at some other innovative solutions, some other materials that we're using now in concrete masonry to create some creative solutions for design. And then just kind of look at some different case studies that we've looked at for different types of innovations. Here's a list of some of the different things that we're going to talk about. As you can see, the front end is really going to be looking at prefabrication, either masonry lintels or prefabricated masonry walls. We're going to look at a little bit of some non-load bearing interior and exterior walls. Still think it's kind of innovative because we don't have a lot of people considering unreinforced masonry for, say, interior walls, but then from the exterior walls, there's some unique ways that we're connecting those exterior walls to surrounding structure that I think is a little bit innovative. Concrete brick solutions. I think there's certainly some different types of solutions that we can consider using concrete brick applications. Offer some, I would say, unique solution opportunities. Speaking of unique solutions, 32-inch block, so larger, longer blocks that can be placed with certain types of construction techniques. Insultech, high CMU, other types of proprietary systems and materials that are being used now within masonry design, masonry foundations, not necessarily new innovation, but certainly some of the different practices and documentations for making masonry foundations of today being efficient. I think that there's some really good practices that can be put into play that I think are relatively innovative to get masonry back into foundations. We're going to look a little bit at some of the different construction techniques. A mule, kind of what is a mule? What does it mean to masonry industry? Masonry control joints and movement joints. I think there's some pretty innovative things that we can do in that respect. Some precast lintels, shoring ideas, and internal bracing. All things that we've talked about some of these different things through the years, and we're trying to reintroduce some of the stuff, trying to get it more widely used in what I would call best practices for masonry design. Let's start with prefabricated masonry. I think there's some really cool things that we can look at for prefabricated masonry. So it's not just flat wall panels. We are doing a lot of different things with prefabricated masonry. Here you can see in the picture below, there's a prefabricated concrete masonry dugout. So kind of a 3D element. It's got some wing walls at the end. You got some unique shapes that you're able to build. You can see in the image above, you can see a long span lintel element and some pier elements with an integrated kind of thickened pier element for masonry design. We have shaft walls that we've considered, several different pieces of shaft walls or an entire shaft wall that we can look at. And a lot of this prefabrication, this goes back to the image below is going to be an actual exterior application, a veneer, prefabricated veneer panel that was built like in the 80s and 90s. Vedovitz was a company that was around for quite a while doing some exterior masonry panels, like I said, but then shaft walls also from a complete shaft, a four-sided shaft wall that we can also prefabricate. So why do prefabrication? Obviously, prefabricated work can be protected from changeable weather conditions. Again, when we look at protection, that could be a tent on site, or it could be a warehouse type facility where we're doing some of the prefabricated masonry elements. So controlling weather conditions to make sure that you can always build with masonry is certainly really, really important. Consider design features that might be too costly or labor intensive on site can be carried out in a factory. We have prefabricated elements that we're considering doing post-tensioning for. So post-tensioning might be a little bit different for the masonry industry, but it's things that we're seeing being implemented more and more, something that can be done in a factory setting. So you could do prefabricated masonry lintels or prefabricated elements and post-tensioned or pre-tensioned elements, or depending on the different construction techniques. More control can be exercised over materials and construction work to kind of ensure a superior quality. You can really kind of put it into a production style, having crews move to different stations within the actual controlled environment, again, warehouse facility or something like that. And then the on-site time, can certainly be shortened. So there's some huge cost savings when we can save on the overall constructed time, and time on site is certainly very valuable. So a lot of the same reasons for prefabricating other materials, there's going to be some of the same reasons that we're going to consider for prefabricating concrete masonry elements. So prefabricated masonry lintels, that's probably a really simple, easy place to start for prefabrication of masonry. Looking at some of the simple elements that you can construct, defining the area above an opening, a lintel element. You can prefabricate certainly a portion of the lintel if you have enough reinforcement to say shear connect other courses and additional courses to the design. But doing say a single course or multi-course lintels, just a couple quick guide, something around 8 feet we probably could do with single course. Longer lintels, maybe it's going to be multi-course prefabricated elements. Looking at some of the different components for a prefabricated masonry lintel, you're going to have, again, the different types of block. We're going to have a bond beam block that maybe is going to be used at the top, or second course. You're going to have lintel blocks at the bottom. We're going to have vertical reinforcement that ties into the wall above. Now, sometimes we don't necessarily need to have the bars sticking out. Sometimes we can use a form saver dowel, something like that the vertical reinforcement can be screwed into once we get on site. We have a lifting mechanism. Here's a lifting loop that goes around some of the reinforcement in the lintel. And then lastly, here we have a void at the end. Depending on where the jam reinforcement would be, maybe putting the void at the end cell, or maybe even 12 or 16 inches in from the end, allows that jam reinforcement to come up through the lintel to have the built masonry conditions still be the same as if you would have built it on site. So having a very nice integral system, even with the prefabricated element. So again, prefabricated, here you can see again a couple examples of some different elements that were prefabricated. You're going to want to be very careful about lifting and moving these elements. A lot of times the prefabrication, moving and lifting, can be some of the forces that the prefabricated element might only see during that time. Once it's set in place and you have additional courses added to a lintel, you're going to have a lot more capacity. So some of the controlling load conditions might be in the moving and setting of a prefabricated element. And that's the same for a lintel as anything else. But here you can see a project where there was I think there was over 70 prefabricated masonry lintels, something that was built on site. And then all of these were flown and set in place. All of it led by the contractor. The contractor was interested in saving time on site, ease of construction on scaffolding by just coming in and setting these things in place. Similar contractor had another project where they actually built a whole series of lintels. Here they actually built the construction pad and used some other masonry materials to create a station system, so they could build many different prefabricated masonry lintels all at the same time. Here you can see again some reinforcement, some horizontal reinforcement at the top, but then also some of the spaces and voids being incorporated into the end cells of the lintel for the jamb reinforcement to come through. Next, we're going to take a look at prefabricated walls, prefabricated masonry wall elements. There's a lot of different things that we can do with prefabricated masonry walls. There's a lot of different ways that they've been built, depending on the contractor, depending on the site and the conditions. Here you can see shaft walls that we considered and designed. We actually built in the ends, the corners of these shafts to have a reinforcement exposed with a coupler that was used to tie the reinforcement from one shaft wall to another. So here you can kind of see that built on site and set on site for these shaft walls. You can see you also have openings at the ends of the walls. We actually can see in this image, you can see some actual support locations for some of the load-bearing beams that are going to be sitting on these shaft walls. So they're load-bearing masonry elements that are prefabricated. So we have a lot of coordination that we had to consider and develop and build into the prefabrication of these elements. You also have panels, veneer panels that you can build prefabricated. Here's an example of some brick ones, but you can certainly do this very same thing with concrete brick. So we can build these panels. You can build a whole system of these panels so that these panels can be built and set into place. A herringbone pattern might be something a little bit difficult to build on site. So you can build these elements in a shop environment, again, with a molding, setting the mortar, and then actually erecting them and maybe doing some field applied mortar as well. So here you can see those elements. You can see more veneer panels that are being lifted and set into site, set on site. You can see there's different types of reinforcement that we can utilize, again, depending on the different types of conditions that you have for the elements actually lifting and setting some of these panels. We maybe have different types of reinforcement conditions that we have depending on the size and location of where these panels might be set. So prefab veneer panels are certainly going to be important elements to consider. Those prefab veneer panels can also be set on entire prefab blocked walls. So this is a project that we did for a company in Iowa, Seedorf Masonry, built these panels and set all of these concrete masonry panels for the entire building, the entire warehouse portion of the building, I should say, and then actually prefabricated the veneer panels to hang off the side of the concrete masonry block panels that were behind it. So again, prefabricated masonry was utilized in this project. The time on site was really condensed by the fact of all the panels being pre-built in actually an hour away. So they were shipped about 50 or 60 miles for this project. So they were built off-site, set in a field, and really set on trailer beds and then shipped down to the facility where they were erected here on site. So again, you could see some of the panel lines, so you could see how some of the different elements were erected and set in place. You can actually see a little bit unique panels, bond patterns. You can see running bond running vertically for these panels, kind of a unique application that the facility wanted to show off. You actually see from the inside the actual concrete masonry block panels were actually built also with running bond going vertical. So the panels were actually built horizontally, reinforced in the horizontal setting, and then rotated, set on trailer beds, and then lifted and set here in place. So again, you could see here two different panels, one that was prefabricated on the right with the running bond going vertical, and then the site set panels on the left where you can see the running bond going horizontally. So again, a lot of different options for prefabricating these masonry panels. Sometimes you just have a lot of repetitive panels. These are prefabricated concrete masonry panels that were used for correctional facility. So again, it wasn't really so much about the a very difficult design. This is just a very repetitive design, something that they could prefabricate a whole bunch of these. So again, they could speed up the time on site for the construction of these cell areas. Here's another shaft that we designed. We had prefabricated shaft walls. You can see at the ends of these shafts we had C-shaped prefabricated concrete masonry elements. We had some openings, so they were perforated walls, perforated shear walls in the design, and again incorporating all the different connections for these panels. Really allowed for the panels to be all pre-built, or mostly pre-built. You can see in the images on screen, you can see all of the gray elements are going to be the ones that are prefabricated. All of the white elements were actually built on site, just due to different conditions of the prefabrication. We wanted to build everything above grade, so everything in the basement and the white was built on site. Once we got the precast planks set, and we could go with the precast floors and then the prefabricated shaft walls above. So you can see a few different images here of them actually constructing them in a warehouse facility. All the different reinforcement connectors that are being used for these prefabricated elements. More shaft walls being lifted and set in place. You can see the corners. If you look really close at the image on the upper left, you can see actually one of the couplers being used to splice the reinforcement from one panel down to the panel below. And a few images a little bit further away from the shaft walls. Quick thank you out to Pat Conway for some great images here for these panels built, again, on site. So some of the challenges with prefabricated masonry, using some of the different lifting mechanisms, we had to make some modifications for a lot of these mechanisms are built for and designed for precast concrete elements. So again, it's a little bit different challenges when you have setting these mechanisms, these connecting mechanisms within a confined cell can create some challenges. So we had to overcome some of those challenges when we wanted to develop some of the different connection points for these different prefabricated masonry items. Some of the key points for masonry fabrication, obviously the essentials of masonry. We have to make sure that we understand the capacity of masonry, making sure that we understand the purposes to simplify and speed up. We don't want to reduce the overall capacity. When we prefabricate, we certainly want to build in plenty of strength in the overall design. We have a lot of different avenues for prefabrication. We can do entire shaft walls, we can do wall panels, and we can do lintels, or we can do some combination of all of the above. Next section here, we're going to look really quick at some of the other innovations. Again, the partition walls, really the simplification of them is what I'm going to call the innovation, pulling out some of the reinforcement, simplifying some of the connections for these walls to try to, again, bring down the cost, bring down the elements that you need in place, considering thinner walls or unreinforced and ungrouted partition walls to save a lot of materials in design. Some of the different top of wall anchors, these are relatively new. We see people using these in a mixed kind of capacity. Sometimes we are able to design some of these for different mason contractors. Sometimes engineers like to use something that's much more expensive and a lot more elaborative at the top. But again, partition walls, we have really light loads. We really just need to consider the minimal connections that you need at the top and at the base to keep these elements efficient. So that goes for the interior walls, but also exterior walls. Again, if we can pull out some of the reinforcement, we can simplify some of the connections. We really can save a lot for some of these exterior non-load bearing walls. So sometimes these are used obviously for architectural reasons, but having a chart like this so that you can reinforce them in a minimal fashion, and then consider some of the similar connections at the top. Again, we're getting some requests for doing similar types of connections at the exterior walls. And again, they're going to have higher load demand. So we're going to have, larger rod diameters, larger connectors, larger plates that are going to need to be used. But again, a lot of this information we can put into a little guide for partition walls. And then we have also one for exterior walls that people can download. Concrete brick applications, I think there's a lot of different usage, obviously, for concrete from an aesthetic perspective. I downloaded this from a CMHA Tech note, all the different architectural means for concrete masonry. So whether or not you have split face, you have ribbed, you have sandblasted or glazed facing, you could also have scored or ground or burnished block that you could use, striated or slump units. So all kinds of different options for creating some sort of an aesthetic appeal for the concrete elements. Now, doing that on a full unit or looking at a concrete brick. So concrete brick is really going to give us options for doing concrete elements from 4 inches to 12 inches wide. The 4-inch element could be unreinforced, kind of in a cavity wall construction. But once you go to 6, 8, 10s, and 12s, obviously we can do reinforcement. So you can have concrete brick in a single width wall application, but we also could use concrete brick in a cavity wall, especially again if it's 4-inch. A 4-inch concrete brick utilized in a cavity wall could be used very similar to the clay option. You also have a composite wall, which is essentially you could have 2 reinforced walls that would be connected by a collar joint. And so a composite wall would really be just kind of an overall thicker wall by having a concrete brick option and a concrete backup wall. Composite walls are not used when you have clay and concrete, but if you have concrete and concrete, certainly looking at a composite wall could use a thicker wall construction. You could use more aesthetic options on the outside and something different on the inside. But composite wall is going to end up being kind of something like the single width wall. You also have a diaphragm wall. Diaphragm wall would be kind of 2 separate whites that are built with some space in between. The diaphragm wall, the purpose of it would be to go kind of super tall with your design. You can connect the 2 whites with what we would call diaphragm walls, connecting them together so the internal width and the external width would actually work together for the out of plane kind of bending capacity. So it's a really creative, great way to get a lot more capacity. But again, using concrete brick that can be reinforced on the outside and inside certainly gives you a lot more options. And again, anytime that we're going to do any conversations about prefabrication of a concrete brick application, again, we're going to have to use at least a 6-inch thick concrete brick to actually get to a design that can be reinforced so that we can lift and set into place. All right, some other innovations beyond the concrete brick. If we looked at 32-inch block, Insultech, high R CMU, these are going to just be new products that are going to be available for use in concrete masonry design. So the first one I'm going to look at here is post-tension masonry. This is actually codified. It's not so much of a new idea. It's been around for quite a while. It's been used in different parts of the country and a variety of different types of construction in full building designs. So post-tensioning, there's going to be some new products that would be or necessary products for anchorage at the top and bottom. So it's a little bit different construction when we look at the typical masonry wall design construction, but certainly there's a lot of potential with post-tensioned concrete masonry. So if we consider the prefabrication, I think there's a lot of opportunities there, but even the site-built post-tension masonry, just again, considering some new materials for anchorage at the top of the bottom, most of the other materials in between could certainly be your typical masonry units. 32-inch long CMU, this is going to be a product that's available here in the Midwest. Again, utilizing large blocks like this, very similar to prefabrication. It's giving us large units that we can set relatively quickly. The purpose of them is the speed of construction. Certainly when we get to certain size units, they're going to get pretty heavy, so doubling the size of them is going to be more than maybe one person can safely lift on site. So we're going to have to get to some unique construction techniques, so we're going to talk about that a little bit as well, but definitely consider and certainly maybe you don't necessarily have to specify anything different as a designer, but definitely recognize that this is going to be a great option for the overall construction of a concrete masonry wall. Insultech is going to be another product that's offered from a certain manufacturer in the Midwest. As you can see here, it's an actual concrete masonry system that's got an integrated insulation and water barriers, and an exterior white that can be concrete, could be clay, could be a variety of materials. So Insultech is going to be another proprietary system that gives us a lot of different options and opportunities for an aesthetic, but kind of a cavity wall type of construction that you can incorporate into your designs. So here's a couple different images for Insultech. So you're going to see it's a pretty standard concrete masonry unit that's going to be in the backside. Really, it's going to be a high strength concrete masonry unit. So oftentimes the F'(M) when we're using Insultech is going to be able to be an F'(M) of 3000. So certainly that can be advantageous for different types of designs, for making sure you utilize that full capacity. High R is another similar product that's got the Weiss, but now the insulation is inside of the cell, so that's going to be some different modifications for the overall capacity. But again, making sure that you recognize where the insulation is and how you're going to have to grout and reinforce those elements. But you certainly can get some pretty good thermal properties, and it's a good, be kind of a unique solution for a single wide wall. There's other materials that we're also seeing being utilized more and more in concrete masonry. Carbon cure is aiming to reduce the amount of carbon in concrete. So doing that in a concrete masonry solution is certainly going to be a very unique application for lowering the carbon footprint for design. So there's several different companies that are looking at reducing and creating low carbon concrete masonry units. Next section, again, masonry foundations. Again, this might not seem like an innovation. This might seem like a little bit of a blast from the past, but I think that it's worthwhile bringing up again, because I think with some unique perspectives on masonry foundations and understanding what the actual availability is for the capacity of masonry utilizing this perspective, really it comes down to good design, good details, and reliable construction. Once all of that is in place, we know that we can use concrete masonry in a foundation wall. And really, I think this is a good topic to bring up right after looking at some of the low carbon alternatives for masonry. If we're looking to increase the sustainability or reduce the carbon footprint, I think there's no better way to do that for a project than to use a partially grouted concrete masonry foundation wall solution. So there's a variety of different basement walls or stem walls. All of them can be partially grouted and reinforced. But again, good design, good details, reliable construction make this a possibility. There's some really nice guides from CMHA to look at all the different elements that need to be in place. But there's no reason why concrete masonry can't be a very good part of the building solution. But again, a lot less material. In fact, I even say you're not really that serious about lowering your carbon footprint if you haven't built with partially grouted concrete masonry foundations. So again, a lot of different notes, not so much about masonry, but really about proper site conditions, proper ways to get water away from the site to make sure that you have a site that's, good, has good drainage, and getting the water away to make sure that that doesn't cause any high load situations. But again, there's a lot of different details that are here available from another CMHA tech guide. Really, the key is getting the water away. So having a proper site, having waterproofing, having insulation in the right spot can certainly lead to a very successful masonry foundation design. Next, we're going to switch over to some of the different innovations in terms of construction. The first one that I'm going to look at is looking at the mule, because a lot of times with masonry foundations, some of the limitations come into place is that the fact that the blocks get just too large. If you had an 8-inch wall above and then 2-inch insulation, 2-inch airspace, and a 4-inch veneer applications, that's a 16-inch wall, while a 16-inch foundation block is relatively thick. So recognizing that that's a pretty large, pretty heavy system. So whether or not we were talking about the 32-inch long, blocks that were available, and I just talked about that as terms of an innovative material, just a 16 by 16 is also going to be pretty heavy. So we see more and more of these systems called mules that are actually used to aid in the setting of concrete masonry system. So it's basically a big robotic arm that can do all the lifting for you. You can lift and set them into place. You can have a whole series of these. As you can see on this site, they have a series of mules that are used to set some units quickly, larger units, thicker units. So if, in terms of building thicker walls, utilizing mules to build and lift some of these very heavy elements is going to be very key to developing the design. Other parts of developing and building thicker walls is certainly you could prefabricate thicker walls. Prefabrication, you're definitely going to have for the panels that get built, a crane that lifts and sets them into place. So again, whether it's 8 inches thick or 16 inches thick, we are going to have the cranes that we have available at the construction sites to lift and set some of these larger elements as well. So whether it's a mule or whether it's a full crane, we have a lot of different ways that we can set some of these thicker concrete masonry units. Control joints, we're going to talk about control joints a little bit. There's a whole session on control joints and different things that you can do for control joints with masonry. Really kind of looking at trying to improve upon this system where we have windows that are becoming very repetitive within a construction, looking at different ways that we could actually reinforce these elements so that we don't have to have so many different control joints, breaks in the overall panel, and really reduction in capacity with some little bit more knowledge about materials and thinking about how we can run reinforcement continuous, whether it's bond beam reinforcement for lintels or joint reinforcement or sill reinforcement. A lot of that gives us the opportunity to make continuous masonry elements. Here you can see a case study where we did this for a project with, again, multiple openings. So building a little bit differently with movement joints is definitely an innovative way to build with concrete masonry that I think is kind of changing the way contractors are looking at some of these projects and some of the different opportunities that they can implement in their designs. Next, we want to look at precast lintels within masonry walls. So we talk a lot here at Forest about utilizing concrete masonry lintels for masonry walls, how those masonry lintels can be an integral part of the overall wall design solution. The masonry lintels should have reinforcement that extends and crosses with jam reinforcement that come up the vertical side of the opening and really kind of creates a very robust system. You're going to have a lot of integration between the lintel elements and the wall above and the lintel elements and the jam elements of the wall. So it really does create a very robust solution. So when I talk about precast that can achieve similar results, looking at precast lintels that look like these, this is one of the products that you can utilize for precast concrete that can be used within concrete masonry walls. So these would be essentially elongated concrete masonry lintel units, right? They have end relief at the end for the jam reinforcement to still come up through. So looking at precast concrete lintels to be used within concrete masonry walls, making sure that you have the right actual elements selected. So this isn't a rectangular section that's going to be maybe thicker than the overall wall. It's not going to be a rectangular section that has no attempt to making an integral element with the rest of the masonry wall around it. These precast elements here, for example, they use tendons to reinforce the concrete for being able to span the opening during construction. Then you can certainly add additional reinforcement to the unit to span the opening for the life of the structure. But really, this company does make a lot of attempts at making construction a lot easier, shoring a lot easier by not having it even be needed at all. It's going to be another concrete element, so it integrates well with concrete masonry that you're building around it. And in fact, here you can see a project that we utilize the precast lintel that is integral with the rest of the concrete masonry wall around it. So there's several different manufacturers. Here's another manufacturer. We can see concrete lintels that again look like stretched out, elongated U-blocks for the overall design, making sure that you can have a vertical bar at each end and have additional reinforcement for, say, the built construction. Speaking of shoring and possibly eliminating shoring, but there's other ways that we can resolve shoring in some very creative ways. There's new shoring companies that are coming out with different types of shoring systems so that the shores can be reused. These particular shores are going to be elements that actually get set in place. As you can see here, you can have a 3-foot version, you can have a 6-foot version. If you have 6 feet, you have an additional support that you put in the middle, kind of a post that could be utilized. But they're really elements that can be reused. So when you set these in place, you build your concrete masonry lintel above it, and you can build the rest of your wall and then remove the shoring. So they actually have ends that project, that telescope out from the ends so that they can span the opening. But then once you have everything built, you can tap those scoped ends into the rest of the channel and then remove the steel element from design. So you can see here it's utilized on a long span condition where you have many different shores that are put into place but then removed. So really kind of we covered 3 different ways to span openings. I think shoring has been kind of a little bit of an issue for openings in masonry walls. We first talked about precast concrete masonry lintels. Those can be certainly prefabricated, set into place, no shoring needed. We talked about precast lintels that look like and have the same material, concrete, that are being used now within masonry construction. And then lastly here, a proprietary product, or there's other similar products that can be utilized like this, that you could reuse steel shoring, take the system out and actually put it back into a future project to build a concrete masonry lintel around it. So a couple different options for replacing shoring or creative shoring that can be reused. Last little innovative idea. Again, this is going to be one that's been around for a little while. Internal bracing is going to be something that we have talked about in the past, but I see a huge resurgence of it here in the last several months to a year, which it's a really great creative way to take essentially there's a guide that was created by Mr. Scott Wakowitz. It essentially looks at bracing for masonry in a unique way. When we developed a bracing guide in the masonry industry several years ago, what we look at is we look at a lighter loading condition than the final condition for designing the braces. So for designing these angular steel members for bracing the walls. So when we have those lightly loaded conditions, we're sizing the bracing, we're sizing all the anchorage based on that. Well, the internal bracing guide essentially uses the early strength of masonry to allow for the masonry element to support itself in a cantilevered condition off of the base of the design. So really some of the very critical elements is going to be a fixed base. Looking at internal bracing is having fixity at the base of the masonry wall so that the wall can essentially cantilever up and then be able to resist some of those early pressure loads. So there's different stages. There's an initial period, an intermediate period where we recognize the capacity of masonry that you have when you are building the wall. Certainly if the wind loads get large enough, then you have to evacuate the site and that can be used. But that actually is a pretty significant wind load. So it's not like just a minimal load is going to bring the wall down. Internal bracing recognizes the early strength of masonry is a very creative way to build masonry walls, to not have to put on external braces on the walls. It really does have a lot of benefits to the overall schedule cost for the project. It really does clean up the site quite a bit. So it can be a really, really good creative way to do design for masonry walls. So with that, we're going to go ahead and wrap up. You can see that there's a lot of different solutions. There's a lot of different innovations that we've covered. We have prefabricated masonry lintels. We have prefabricated masonry walls that we looked at. We looked at non-load-bearing interior masonry walls. We looked at non-load-bearing exterior walls and some of the different connections that are utilized within those. We looked at the concrete brick applications, how you can use concrete brick to certainly in a variety of different, maybe single width walls or cavity walls or composite walls or diaphragm walls. So there's different options that you can utilize that. You actually have different systems. You have longer 32-inch block. You have blocks that integrate insulation with the system so that you can have some water and insulated systems that can be set in place. We're talking more about masonry foundations. Again, it's really more about site conditions and overall construction techniques for those foundations. But getting into the construction techniques, the mule is giving us the ability to talk about those longer blocks or those heavier blocks or those thicker blocks for foundations. Mules are able to give us a mechanical arm to lift and set masonry in place. There can be a series of them set up on a job site. Could really speed up the overall construction. We looked at precast lintels. We looked at different movement control strategies that can be utilized within masonry design. We looked at shoring. So again, prefabricated masonry lintels, precast lintels, new shoring ideas, all giving us new ideas and new ways to build openings within masonry walls. And then last but not least, an internal shoring that we can utilize to actually have built masonry with just the pre and early strength of masonry being considered for design. So with that, we're going to go ahead and wrap up. If you do have any questions on the presentation or any of the ideas that we put forth today, feel free to reach out to me at the email that you see on screen. So thanks a lot for your attention.